guys, welcome back. And today we're doing 2.7, solving equations with one variable. And so what we're going to be learning about is solving rational equations, really is the main thing. And talking about extraneous solutions. So let's just go ahead and just dive right in. So we have equations where if we have f of x and we have g of x, if they don't have any common factors, then the zeros of the functions are f of x of the equation. We're going to have fractions. And so basically, we're going to have to get rid of these fractions in order to solve for x. And so we want to basically get rid of g of x. So we are going to be finding the least common denominator. Same thing that we did with like normal fractions without variables. We're going to be finding the least common denominator of all the terms of the equation, and then we clear it of all the fractions, and then we can solve. If you multiply or divide by equation containing variables, you have to double check because you may get extraneous solutions. So you may get numbers that are actually solutions. However, when you replug it in, it may give you a 0 in the denominator, which is super duper illegal. Okay, so make sure that you check that because we can't have any zeros in the denominator. So let's go ahead and get started. So basically, my goal for this lesson is just to do lots of different examples with you. So let's look at this first one. Is very basic. We have x minus 2 divided by 3 plus x plus 5 divided by 3 is equal to 1 over 3. So if you notice here, all of these are being divided by 3. All of our denominator is 3. So whenever we want to get rid of fractions, we can multiply everything by, we want to get that least common denominator, least common divisor. Here, it's 3, obviously, because they're all 3. So two ways to look at it. We can multiply everything by 3 in order to get rid of that 3. So our denominator is 3, so we multiply through by 3 to cancel it. So cancel, cancel, cancel. Or, since all the denominators are the same, basically we're just taking that numerator of x minus 2 plus x plus 5 is equal to 1. Okay, look, make sure you watch here. If that's a negative, you may have to distribute, change signs, and things like that. But we're professional mathematicians here, so you know what to do. So now we just solve for x. X plus x is 2x. Negative 2 plus 5 is a 3 is equal to 1. Subtract 3 from both sides, so we get 2x is equal to negative 2. X is equal to negative 1. Okay, we don't have to worry about any extraneous solutions because our denominator here is just 3. We're not going to divide by any variables, so we are good to go. Here is your answer. Bada bing, bada boom. Okay, let's do another one. So that's as easy as it's gonna get. We're going straight to the tippity tap. Okay, so the next we have solving for x, and so we need to clear the fractions. And so looking here, we have a denominator of an x. Okay, and so the least common divisor is x. Okay, so you may have to factor. Basically, we want to cancel out that x. And by doing so, we can multiply everything by x over x, okay? And so that will end up, or just multiply everything by x. So we have an x here, we have multiplying by an x here, and we're multiplying by an x here. So x times x gives us x squared. X times that cancels, so we just have our plus 3. And that's equal to 4 times x is 4x. So I multiplied each term by x in order to cancel that out. So now we don't have any fractions, and now we can just solve for x. I'm going to get everything on one side. We have x squared minus 4x plus 3 is equal to 0. Okay, I'm going to factor. To multiply to get x squared, we have x times x. To get 3 and add to get negative 4, we have a negative 1 and a negative 3. Negative 1 times 3 gives a positive 3. Negative 1 plus negative 3 gives us a negative 4. So we have x minus 1, and we have x minus 3, and that equals 0. So now what we can do is set each factor to 0, and we get x is equal to a positive 1 and a positive 3. Okay, before we say we're done, bada bing, bada boom, let's double check to make sure we don't have any extraneous solutions. Here, our only denominator is that x, so basically we cannot have a solution of 0. In this case, we have a solution of 1 and 3. Both of those denominators can be put in our denominator, so both are solutions. Okay, so let's look at another one. So we have x plus 5 is equal to 14 divided by x. Okay, so again, we want to clear this fraction. So our only denominator we have is this x. So we're going to multiply this by x, and this by x. X times x gives x squared. 5 times x gives 5x. And then 14 over x times x cancels to get just 14. Okay, we want to move the 14. Move the 14. So we have x squared plus 5x minus 14 is equal to 0. Again, another thing that we can factor. Multiply x times x to get x squared, negative 14. And then we have a 5 at the bottom. So our multiples of 14 would be 7 and a negative 2 to add to get 5. So plus 7 minus 2. Okay, set both of those equal to 0, and we get x is equal to a negative 7 and a positive 2. Before we circle, make sure we cannot have a 0 as one of our solutions. Both of those can be used as a denominator, so we're good to go. Okay, oh, we're getting a little bit harder. Here we have 2 and then minus 1 over x plus 1. And that's equal to 1 over x squared plus x. So here we may have to do a little bit of factoring, okay? And so looking here, this one does not have a denominator. This one has a denominator of x plus 1. And this one has a denominator of x squared plus x. So first thing, always look to see if we can factor anything, okay? Well, this one, nope. But this one, yes, they both have an x. So I'm going to factor out an x. So we're going to factor out an x, and so we have x plus 1, okay? So now, if you notice, we already have an x plus 1 as one of our denominators, okay? And this has a denominator of 1. This has a denominator of x plus 1. This has a denominator of x times x plus 1. So basically, the least common divisor would be that x times x plus 1. So what we're going to do is we're going to multiply through by what the denominator is missing. Okay, so the greatest thing that we have is this x times x plus 1. So this one we're not going to do anything to. Okay, this one right here, we are missing an x. So what we're going to do is we're going to multiply the top by the x and the bottom by x. Okay, and the reason why is so that way we have that x in the bottom. Okay, this one, we're missing both the x and the x plus 1. So we're going to multiply times x plus 1 to the top, and the x times x plus 1 at the bottom. Okay, and so by doing that, we will have the 2x times x plus 1 over x times x plus 1. You don't have to do this step, but I'm showing you why mathematically it works. Minus, and then we have an x times, 1 times x is just the x, and then x times x plus 1, and then that equals 1, sorry, I really blanked if you hadn't noticed. I was like, why are we multiplying? We're not multiplying here. Remember, don't forget that we didn't multiply here because we already have that x times x plus 1, that greatest common divisor. We already have that one. So we didn't multiply this one. This one did not change. All I did was change that factor. Okay, so if you notice, all three of these denominators are that x times x plus 1. So basically, we just multiplied each fraction by what the denominator was missing in order to get it to this, okay? So now that we have that, I'm just going to look at this top part, kind of like what we did with our very first example. Now that looks like that. So we have 2x times x plus 1, and then minus x, and that is equal to 1. So now we can solve for our x. So distribute 2x squared plus 2, and then minus x is equal to 1. Subtract over, sorry, we have 2x squared, 2x minus x is a positive x is equal to 1. Move everything over, subtract our 1. So we have 2x squared plus x minus 1 is equal to 0. So now we can factor this. If you notice, we have a is greater than 1, so we're going to have to slide and divide. So we slide to get here, so we get x squared plus x minus 2 is equal to 0. Okay, so if we do our factors now, we have x, to get our negative 2 and a 1, we have a positive 2 and a negative 1. Okay, so then we have to, since we multiplied by the 2, we have to divide by 2. Okay, so that would be x plus 1, and that would be x minus 1/2 equals 0. So here our two solutions are x equals a -1 and a positive 1/2. Okay, before I circle, we have to go back. Okay, so if you notice here of a -1, if we put a -1 here, -1 plus 1 gives us a 0. That is illegal in math terms, and same with this. That would give us a 0. So x is not equal -1. Our only answer here is x equals 1/2. -1 would be considered an extraneous solution. So it's a solution, but it's like not a solution. Okay, so your only solution here would be 1/2. Okay, so let's do another one. So we have 2x over x minus 1 plus 1 over x minus 3 would be equal to x squared minus 4x plus 3. So again, we are going to, first thing that we need to do is factor, okay? A little hint, like you have these two right here. So a little hint, these probably may end up being that way. Don't always think that, but you know, double check. So we have x times x. Okay, to multiply to get a positive 3, but add to get a -4, -1, and a -3. So those go right here. Okay, so we factored that. And so basically, if you look, okay, this would be our, the greatest common divisor. So basically what we need to do is we need to multiply the top and bottom of both of these of what we're missing in order to just work with our numerators, okay? So this one has everything, the x minus 1 and the x minus 3. If we looked at this first term, we have an x minus 1, but we don't have an x minus 3. So we need to multiply through the top by that x minus 3, okay? And then here we have an x minus 3, but we don't have an x minus 1. So we multiply the top by an x minus 1, x minus 1, same with the bottom, okay? And so now all of the denominators are x minus 1 times x minus 3, so we don't have to really worry about that. All I'm going to bring down is the numerators. So we have 2x times x minus 3 plus, and then 1 times x minus 1 is just x minus 1. Okay, and that is equal to 2. So now we can simplify. Distribute, we got 2x squared minus 6x, and then plus x minus 1 is equal to 2. We, can subtract our 2, we get 2x squared, and that would be minus 5x, and that would be a minus 3 is equal to 0. Okay, slide and divide, so let's multiply to slide, so x squared minus 5x minus 6 is equal to 0. So the multiples, multiply to get -6, but add to get -5 would be a -6 and a positive 1. Okay, so that would be x minus 6 times x plus 1 is equal to 0. Split our 2, divide our 2. So divide by 2, we get, come up here, we get x minus 3, and we get x plus 1/2 equals 0. So that means that our solutions are 3 and a -1/2. But wait, always confirm. So if we have a this is a positive 3, x equals 3, and a -1/2. Again, that looks like another -3. Are you guys? X equals a positive 3. Okay, so if we have a positive 3 in here, 3 minus 3 equals a 0, can't do it. But we can have the -1/2. So our extraneous solution is that 3, and our solution is a -1/2. So if we looked at the graph of this, let me erase some things so that way we can actually see the graph and see what I said with the things and that's not a good idea. So we said that x equals 3 was extraneous. Our solution was just that -1/2, okay? And so our two possible solutions, for example, 3, were x equals -1/2 and a positive 3. Okay, by looking at the graph, you can see that x equals 3 is not a solution. So 1, 2, 3, look, it's an open circle there. That's a hole, okay? And so that would be your extraneous solution. And then the -1/2 would be your asymptote, okay? Cool, I hope that helps. Or not your asymptote, y'all, it's your Okay, so yeah, that's what we're doing. Cool. Let me know if you have any questions. I think that's it. Yeah, 6 total questions. Let me know if you have questions, and we will rock and roll. Though we're done with chapter 2. Okay, bye.